I could just sit there.
Okay, we should be good to go.
Okay. Okay, welcome to our weather discussion. This will be the next to last one of the term. We won't do it on the finals week, but we will next week. And today we have our professional master's students, Natalie, Naquin, and Derek, are going to give our discussion today. I think Natalie's doing the current weather and Derek's doing the forecast. So please give them your attention, and any questions you have. As you know, this forum is wide open and largely informal. And so, Natalie, take it away.
Yeah, okay, so, well, that's just a satellite imagery of the United States right now. And I'll get into that in a little while. But I'm actually going to start by talking about the severe weather outbreak that happened in the southeast this week. So, if you didn't know, central Mississippi and a little bit of Louisiana, they were in a moderate risk on Tuesday afternoon. And that actually ended up spinning up some decent severe weather. There were several tornadoes just throughout the region. There were some in Louisiana and in Mississippi. I think a couple in Arkansas too. But yeah, so I'm just gonna kind of get into like kind of what caused that, how that spun up, and like kind of what factors went into that. So first of all, so there were 42 tornado reports, which is a decent amount, and this is not a very common event for November. This isn't really severe weather season. I wouldn't consider it for the southeast. So this was kind of a little bit of a unique event, I would say. But yeah, so there were 42 tornado reports throughout Mississippi, Louisiana, some in Alabama, and okay, so yeah, so no one in Arkansas, but yeah. So that obviously doesn't mean there were actually 42 tornadoes, obviously, but there was a decent amount of stuff going on. So first of all, we're gonna look at the 500 millibar standardized anomalies from Tuesday, or no, not from Tuesday, I'm sorry, from last Friday actually, because those, this trough right here really kind of sets up a good environment for this severe weather event to occur. So you have these really low heights, lower than normal heights over Mexico right here in this trough that's going to move over throughout later in the week. You can see it the trough kind of deepens and really just sets up a good environment for this event. Although really what kind of went into this event mostly was a lot of mid-level and low-level wind shear, because you actually have a deep layer of speed and directional shear from a southwesterly low-level jet, and a westerly mid-level jet, which we will take a look at here. So this was Tuesday. This is the 500 millibar heights from Tuesday. Actually, I'm going to go back a little bit just to show that trough again. So this was last Friday, and you can just see that trough just deepens and goes into that jet. And so this was Sunday evening. Just going to keep going, and then not Sunday. Yeah, the 28th. That was Sunday. Okay, the 29th was Tuesday, yeah. So 500 millibar, you have this those westerly winds going really fast, and we're going to look at, this is 700 millibar, so you can kind of see they start to turn southwesterly, and then again 850, even more southwesterly. So that's really what kind of set up this event, made it a really kind of like the ingredients really came together because of these two features overlapping with each other on this particular day. So yeah, because you have the gradually deepening boundary layer along with the overlapping mid-level and low-level jets that created a lot of directional shear. The other thing that really kind of went into it is you had that warm, moist air mass coming in from the Gulf of Mexico, bringing in all those warm temperatures and kind of colliding with that lower level trough. Those lower heights, that colder air meeting with that warmer, moist air, and again, just really enhancing that potential for severe weather. And actually, on the day of the event, we saw a lot of surface heating. So the morning, like Tuesday morning, there was just not a whole lot going on. It was very quiet, which really just obviously enhanced that potential for severe weather, really enhanced those surface temperatures, lifted those up, and provided a lot of good CAPE. And actually, we can take a look at the CAPE from Tuesday. Yeah, so that was Tuesday at noon. So you can really see from that morning, just all that kind of CAPE just really comes in and sets up a really nice environment for all of that severe weather.
So that, it looks to me like these are isotropes at 850. Okay, yes, a really strong temperature gradient. This really,
Yeah,
the remarkable frontal passage that we had earlier in the week is tied to the outbreak. Maybe it isn't tied to the initial setup. Is that what you're kind of suggesting? It looks like that might be what's going on here. Because right at this point, this is the moment where things start to erupt, is my guess. Is that right? Tuesday afternoon, evening?
Yes, yeah.
Yeah.
A lot of the reports in Louisiana, they started kind of earlier in the day, like in the early afternoon, I think, but as it moved through Mississippi, it was a lot later in the evening.
Okay. Can we see the 500 millibar map at this time on this projection, if we could, Natalie? Do you have that handy?
So.
There. Relative vorticity might be okay.
Yeah,
that's
so
the 500 millibar
yeah.
map. Okay. So we're not really seeing the exact same trough, I think, that you saw on the 27th. This is a different feature, it seems to me.
I think it is, yes, but it was definitely kind of enhanced by, I think, those lower level heights that we're moving through, and kind of was a little bit able to set up a little bit for this other feature that moved through.
Can we click back a few times, staying here, and just see how that goes? Okay.
So that's Monday, Sunday.
Yeah, so that's the first one. That's the one that had the low anomalous heights in northern Mexico. And I don't know what kind of weather came along with that, but the second one's the one up there on the Pacific coast, it looks like, right?
Yes.
Sliding southwestward now in the north-southeastward and the southwesterly flow. And then when we get to this time, that's the thing that's driving the cold pool southward, organizing a cyclone in the central plains, and really strengthening the cold front. So, yeah, maybe there's a connection between a prior advection of warm, moist air at the lower levels, and certainly dry air at mid-levels from the first trough. And then it gets kind of driven into the severe weather event, perhaps, on the second one that comes down. Okay,
Yeah.
let's see.
Yeah, because that first one kind of moved through and just, like I said, kind of just created the setup, and then this one came through, brought those jets in. And you can see these are kind of southwesterly at the 500 millibar heights, a little westerly, southwesterly. So again, even more shear. That really played a big role in the formation of this event and in the severe weather. Because actually, when you look at the photographs, all the photographs from the region were just really kind of crazy, very, very typical for a severe weather event, I think. So, I think that was it for. Yes. Okay. So now I'm just gonna get into kind of the current conditions for today. So obviously this morning we started out pretty nice, although it is getting a little bit cloudier out there. As you can kind of see, we got those clouds moving in from the southwest, I would say, coming in from, I don't know what state that is. Iowa, I think, maybe. Yeah. But yeah, so we have those clouds coming in. That's really gonna be part of the event that's happening later tonight and tomorrow. I'm bringing all that cold weather, which is what I'm gonna get into and what Derek is gonna talk a little bit about. So first, so this is the model run from yesterday at midnight to Thursday at midnight, starting yesterday morning. And so we have this low pressure right here, but actually we're gonna see a low pressure kind of forming on the lee side of the mountain, which I think is a little bit interesting. We have this lee side genesis that makes for an interesting feature, so we can start to kind of go through it, and you see that's where it kind of pops up. And that's going to really bring kind of, well, this feature kind of moves that way, but we're going to see it kind of go almost that way. And we see a lot of warm air advection brought in by that feature as well. You can see very clearly here, you have a pretty tight pressure gradient and all that warm air advection that's going to move through to kind of help set up for the event that we're going to see this afternoon, which is really going to be interesting because it's kind of just a lot of different features that come together and form essentially just you see it kind of moves northward to where we are. And this was yesterday's model run, so it's probably a little bit different now. I think Derek's going to get a little more into that in a minute. But yeah, so we can see yeah, so that it kind of just everything kind of comes together, builds up that setup for the cold front that's going to move through this afternoon and this evening. Like I said, it's a little bit different now, so it looks a little bit more well formed. If you look at it now, it kind of comes right through. That's going to bring a little bit of some weather for us today. Oh, I wanted to look at these. So this was for okay, so this was for midnight today, and you just, if I go, like move through, I have it every 6 hours. You can kind of see the feature kind of bringing all that stuff down here, and then so that's at 6 o'clock tonight, and then midnight tonight. You can kind of see is really where we get into. We have that vorticity maximum right there. We get into the really major weather, and then was the same hour, or yeah, the same time. So midnight tonight at the surface. You can see kind of lines up right there.
How's that related to what you showed at 500 millivolts? It's a nice couple of maps. How do you connect the two physically?
So, well, these are, I mean, you have this this low pressure here, this trough that comes through. This is the 500 millibar map. You have this vorticity maxima, and then you can see here at the same time is surface precipitation along with at the same time, the same location, along with those tight thickness gradients.
Yeah, I guess I'm asking you, how do you connect them through a theoretical idea? What's at play here?
I mean, just really, I think really just you have that trough that's coming in, that low pressure system, and it's causing just a whole lot of stuff, I guess.
Yeah, but by the mechanism of positive vorticity advection by the thermal wind, right? That's the Sutcliffe development theorem at play here. So the forecasted precipitation in the northern part of our state and the presumably the pressure falls over Lake Superior are a result of that PVA by the thermal wind. And that's the conjoining of those two ingredients that you've so clearly pointed out to us here, Natalie. Go back to the vorticity map, please. And Derek, maybe you can do the next, to the next map, but Natalie, put your pointer right on top of that, the maximum vorticity gradient. So go a little further north, right in the gradient region. No.
Oh,
In
okay.
northwestern Wisconsin. In northwestern Wisconsin. You were
Oh,
looking
right
at the
there.
right feature.
Sorry.
Keep going over. Right there. That's where the gradient's really strong. Keep the pointer there, and let's go to the surface map. That's, yeah, and see how the thickness indicates the thermal wind is really strong right there, so that's where you have your PVA by the thermal wind. It's characteristically a little west of the cyclone center at an instant. I found that to be the case. I'm not sure I understand why that's always true, but it is. And that's where that precipitation in the forecast, I think, is coming from, because it's probably not frontogenetic. So that's all I was asking was, put those two together with a theoretical idea that ties them together.
Okay, yeah, so that's pretty much all I have, I think, so.
Okay.
I'll hand it over to Derek.
All right, so, yes. All right, so, yes, I'm gonna start with the cyclone we were just looking at too. Now we know that pretty good. I'll get a couple of different characteristics also about it. So as Natalie was mentioning, as we go through the day, I took the run at midnight tonight. That was my most recent one that I was looking at this morning. Midnight tonight, kind of a similar pattern as it progresses along through. It makes this sudden jump from over Kansas up to right above us. So I'm still not sure why the models are showing that, but I'm trying to look at that too. But along with it, she shows the vorticity maxima along with it. And it falls right along with it, right in there, talking about the Sutcliffe development theorem. And you can also see on it the height gradient right in there. And along with, associated with this high out over here, we do have a lot of cold air advection working with this. So we were talking about this in class just yesterday. You have the low center working in a counterclockwise motion with the high also working in a clockwise motion. And they're working together to strengthen this cold advection area too, which you could see is pushing those gradients further together, which causing this vorticity maxima right up in that similar region right there.
Well, I'm not sure there's a cause between the advection and the vorticity maxima. I'm not sure there isn't, but it's not a direct theoretical
Okay.
link. They're coincident features. They tend to work together in this regard.
Okay.
Up shear of the trough axis, there is anticyclogenesis. Down shear of it, there's cyclogenesis, and that provides the northerly flow, the combination of those.
Right. That's what I'm into. And then also, these are 500 millibar geopotential height anomalies. And there is another further representation of this passage of cold advection down into the western U.S. along with these high passages of higher heights and thicknesses down in the eastern U.S.
That enormous ridge on the bottom of that map, is that, it just looks really bizarre to me.
It does.
You know, it's
I
like
was
this
looking at
huge
too.
dome of,
Yeah.
I was looking at that too,
for
but
sure.
I could never find anything associated with it. I might just not be looking at it clearly. I haven't explored it enough. There's about 3 or 4 other cyclones along with this anticyclone I was going to look at and also discuss kind of going into the end of the semester.
Well, the big anticyclone off the east coast extends all the way to the far western, southwestern Gulf of Mexico. So that's, partly reflected by, or partly a reflection, the southwestern extent of it might be a reflection of that anticyclone
Right.
aloft. And that's pure tropical conditions there and perfectly quiescent.
I imagine that has something to do with the clouds we were talking about before
Yeah.
we started all this.
Perhaps, yeah.
Let's see. And then, yeah, so into tonight, as we go further on, we're called getting a bit of drizzle. I think we had like a 20% chance. Moving on, last I checked with the weather service with their forecast for us. This is associated with as that low center keeps progressing further north. It's the cold advection behind it. Imagine right up in here we probably have that vorticity maxima falling along with it. Let's see, it stays up closer towards that the maxima up here, which was about right here. A little further north right there.
At the same time?
6 a.m. Oh,
No,
12 p.m.
6 hours,
We'll too
yeah,
far
so.
off. So 6 a.m. on 3rd, 6 a.m. on 3rd. So yeah, they have the vortex maxima down over Michigan with the pressure center being all the way up in northern Ontario getting towards Quebec. Let's see.
Yeah, cyclone keeps on outrunning the region of strongest PVA by the thermal wind, which is
It does.
interesting. Does happen sometimes, but
Mhm.
not all the time.
Right, and then along with it, I wanted to show the forecast. We're gonna hit into the 40s today. It's gonna feel nice comparatively, but once that that cyclone passes over us, it's gonna drop cold and it's gonna stay cold, it looks like. I think our high tomorrow was around 27, and there's that low start to pass through. Here comes all the cold air with it, and as it stays there, it just stays out here with it, hanging out with the high right here. Let's see. And then, let's see. And yes, I wanted to look at the QG omega maps also. So this is associated with that low pressure center, that vortex maximum we were seeing earlier. And there is that high causing mass subsidence across the U.S., which I'll dive into it more, but it creates a nice zonal flow just all across the U.S. with these systems hanging out over California, which they'll come into play later on, as we'll see, we'll continue on.
That is really strong subsidence. I'm not sure I see that very often, especially the mismatch between the subsidence being, 5 times or 3 times, I guess is more accurate, 3 times stronger than the ascent just to its east. And
Right.
you imagine that they're connected to the same upper disturbance. That's quite interesting. I wonder what's going on there.
Let's see, we can go over to Alicia's map and take a look at it. So this is,
We at the same time though? Let's make sure we're at the
this,
same
yeah,
time.
I need to fast forward, but I had them all synced up to, this is at noon today. We'll keep progressing on. There's that low associated up right in there, and it's just creating a nice zonal flow all across basically the whole continental U.S. And there's that ridge starting to make himself, or high starting to make himself present in there.
Derek, can you go back to, I just want to make sure I know what time this is relative to the vertical motions that you just showed.
Right, I took,
So this is
this is the
valid.
30 hour.
Okay, it's valid at 6E
Right. That's
on
it.
Saturday.
On
Okay.
Saturday. And this is at 18 Saturday.
So let's go
further
back
on,
a couple of
go back
times. I
a
want to see
little
the
bit.
60s.
So
Okay.
right there. So he's
All right.
starting, he's not as well defined on Alicia's maps, but he's still starting to make himself present. That low is still up right there, associated with the vertical motion from.
And the vertical motion, the subsidence maximum is where you have the very strongest localized cold advection
Mhm.
indicated by the thickness and sea level isobars. That's kind of interesting. That makes sense to me.
There. Mhm.
Yeah, and it leads the anticyclone. But
Mhm.
does it deepen the anticyclone? Does that get stronger? It's like 1,032. Does that get any stronger, or does it just kind of progress? There's 1,036 isobar that shows up. It gets a little stronger.
A little bit stronger.
Not in the same place where the air is sinking. That's interesting. Okay.
Let's see. Press along to, we'll go to the vorticity map also, and this was 6 a.m. on Saturday, so we'll press a little further on. The vorticity maxima stays following the cyclone up there, and like I said, almost homogeneous flow across the entire continental U.S. You start to tail off following the high that was present up here as he makes his way back towards the equator. The winds start to tail off down there. For the most part, they all follow out here. Which with this zonal flow, you're going over the Rockies all right here. And the next few cyclones I want to take a look at, the first couple start as just a couple of relative just areas of not even well-defined storms, just centers of low pressure, almost just ripe fruit for the picking, just waiting for something to come along and help initiate them along their line. Let's see. Let's go along to this one. This next cyclone will progress onto the 4th. Let's see. There's that high again making his way across, and that low still advancing towards the north we were talking about before. Let's see. Actually, no, I was wrong. I wanted to talk about this one next. This one I want to go to Alicia's map. He makes his presence super at 4th. So this is Saturday the 3rd. I progress along. This is where he comes right up here along with his jet max, but he follows it down all the way to that U.S.-Canadian border. We were mentioning earlier it could perhaps be a lee side. I just haven't dove into that one enough.
Looks like it rounds the
Sure.
ridge to me. There's a big ridge over Alaska and northwest Canada, and it comes down in northwesterly flow. And it's like an Alberta clipper in that regard, but it
Right.
doesn't have a lee origin, which many of them often do.
Okay, that's what we were discussing earlier. He rides down all the way, and he becomes, he gives us a small little chance of flurries, but I don't believe it's really gonna happen. It's mainly gonna stay north of the border, maybe clip parts of northern Wisconsin. I don't think nothing is gonna make it all the way down, to us down in Madison.
And what's the mechanism in this case for the risk of precipitation, and where is the risk of precipitation?
Let's see. Let me try to find. So actually, need to go to the sheet map for. This one.
Just try that other set, and then just go to a different map type. See the map type on the
Oh,
far
I see,
right?
okay.
Just go to standard. No, standard weather, yeah.
Gotcha.
And then one of the choices might be precipitation.
Yeah, precipitation and vorticity. I'll follow the vorticity, see if I can
Okay.
follow along with the.
And now you gotta get the time back to where you
Right.
want.
Right. Go to Saturday, around, let's see, yeah, 60, that's, yeah, actually, go back one more. So there is, those vorticity maxes falling down with that ridge, along with that cyclone. Let's see, this was 14, yes. And as you progress it down, it, like I said, it mainly stays above to the north of the Canadian-US border and follows along there and then turns back, following the ridge and the trough back up to the north, back towards Ontario and Quebec. So he might clip us a little bit, but mainly just the northern parts of the state, unless some region forces him, that trough to deepen back across the border. I don't see him.
So what's the mechanism that leads to the potential precipitation that's associated with this?
These vorticity maximums, as he grows closer to the US, let's see, these are height lines in the black. As his height gradient is getting increased right here, there has to be and the vorticity maximum increase. There's going to be PVA by thermal wind and.
Oh, okay, PVA by the thermal wind. So we don't see the thermal wind yet. All we see is the vorticity. So how are we gonna rectify
Right.
that? How are we gonna show that?
I can show the temperature, but I'm also mainly just looking at the height lines, because in warmer temperatures, the heights will be higher up, and in colder temperatures, the heights will be at a lower level. And I'm seeing the height at about 506 right here, and then 540 right here. So there's that's that height gradient right there.
Right.
So I'm seeing that as that gradient gets constricted, goes by confluence, that thermal wind is going to increase, and that's where that vorticity advection comes along with it, and it follows with the pattern of precipitation I was looking at on the model.
There's a little bit mixed up. You can see the confluence in the geopotential height field if there is confluence. It doesn't seem to
Okay.
be here. It's just kind of straight flow with a curve in it over Alberta. So the vorticity is produced by the shear along that line, it
Okay.
looks like in this case. What I'm suggesting is you need to see independently a measure of the thermal wind. There isn't an
Okay.
independent measure of the thermal wind on this chart.
Okay.
So and that's unfortunate because it's such a fundamental thing that we should be looking at. But you have to bounce between charts. So that's another point.
Let's see. So keep going with this. Let's see, that one, and then yes, after this cyclone up north though, I wanted to transition to the ones that start popping up. 3 in a row all kind of pop up in this region just south of the Rockies and near the panhandle of Texas. The first one starting on the 5th of December. So we're at 4th. So there is that first one popping up, and it's really nothing too intense or special. It's a low pressure center with a maximum of still of 1,006. So we're still only 7 millibars off average standard sea level pressure. So it's really nothing too intense.
And notice that it's connected to a thermal ridge that goes all the way through Colorado and then flattens out a little bit more in central Texas.
Mhm.
And that's a sign of a lee side feature. My guess is the 500 millibar flow is from the the west-southwest
Mhm.
across the high terrain of the Rockies.
I think I can see that on vorticity. Now this is 500 millibar. We're at 6 a.m. on the 5th. We'll go to 6 a.m. on the 5th. And
Yeah, look at
there's
that. And there's even a little bit of a perturbation in the height prediction because of the interaction with the Rockies. So that's what that is. That's a lee side feature.
Okay.
without any particular upper level support.
And then that one, we're kind of at the range of Alicia Bentley's max, but I'll show it also. We'll go back to tropical transition and thickness. We were at 6 a.m. on the 5th, yes. This is the same. 3, 4, 18. So that's night. Midnight, right there. So yeah, it's just following that zonal flow of the jets across the continental U.S. And we start to see these storms over here on the Pacific, these northern Pacific features. They come into play later on. This first tropical, or not tropical, I'm sorry, excuse me. This first low pressure center, he doesn't turn into much, I don't believe. No, like I said, it's a pretty relatively weak storm on its own. It needs something to come along and help it out and initiate it along its way. And as it progresses on, it really just doesn't turn into much of a storm. It just kind of stays as a low pressure maximum center of the region. Let's see. And then this is where this third one starts to become involved. Or second, yes. Step forward a couple more. This next feature, I was mainly concerned on this cyclone problem up there. Okay, so the model has changed actually since I was looking at it. I guess I did. I was looking at the different model this morning. We have another one about 1,006, which if you're looking at it earlier, this low pressure center is labeled as 1,006 too right here. So it's still about the same pressure area. Also, it's just now they're not labeling it as the maximum. And then we have this additional anticyclone up in here. This one is one that as he transitions and goes through over the continentals, the continent, he stays relatively weak. He has a few, we'll show the vorticity maximum along with him. You have this vorticity maximum following him along, trailing him back here, but for the most part, he doesn't do a whole lot until he has a chance to initiate a few showers up in here. I was trying to look at the...
You think the cyclone that you're talking about in the Texas Panhandle has something to do with that precipitation over southern Missouri, northern Arkansas?
I'm not sure if he used the cause of it.
How would you determine whether it is or not?
I was trying to follow the pattern of the thermal wind of them, and it doesn't look like it follows a shape of a characteristic of cold advection, because these are higher heights down here, and the cold advection is typically what you see, or the warm advection is what you see with the height.
What about that precipitation in the forecast might clue you into a different type of mechanism? What characteristic of it do you think? Maybe it's linear nature?
Right,
The fact that it's parallel to the thickness lines?
Right, it's following along with that structure where you typically, the cyclone right here, you typically expect to see that warm front come along with it right there.
Well, what's another mechanism to generate vertical motions that will occur in very often in linear bands?
That one off the top of my head, I am not too sure.
What about frontogenesis?
Frontogenesis?
Right?
Okay.
That's going to
Right.
produce transverse circulations, and that means the air rises on one side and sinks on another over a long line. And so in order to have frontogenesis, you have to have differential temperature advection. Is there any
Right.
possibility that such a thing is occurring in that location? Just looking at the pressure distribution on this map.
So looking at the pressure distribution and the height distribution also, pressure distribution and height distribution, I believe there is, basing it off those, like I said, as I mentioned before, you have the lower heights northward of the storm, and then also lower heights following, or higher heights behind it, lower heights right here, excuse me. And these lower heights at the same level are associated with colder air and colder temperatures.
How about the circulation around the big anticyclone off to the east of Lake Superior? What's the direction of that circulation?
That circulation is going to be clockwise.
Clockwise, right. So there's going to be cold advection over western Pennsylvania, Ohio, West Virginia, right? What about the much weaker but still present anticyclone that's right over like Pensacola, Florida?
Pensacola, Florida.
That's the panhandle.
Right.
Yeah, right in there. So what's the circulation around
He's
that?
also going to be.
Okay, so there's going to be warm advection in Tennessee and northern Arkansas. So if you've got cold advection to the north and warm advection to the south, you've
They're
got,
working in tandem.
right,
with each other.
that produces frontogenesis. And it's in the place where that coincides is where you get this forecasted precipitation.
I'll admit I hyper-focused on this section right here. I didn't pay much attention to these two, so that is my fault.
Yeah.
I did hyper-focus in.
Yeah, you have to be open to taking all the tools in your tool belt to the diagnosis of weather systems. You can't succumb to that hyper-focus and thinking about only one mechanism or one feature if you're trying to explain what's going on in the weather.
Right. And then, so pressing on with them, that low, he follows along with the flow, which will pull up that vorticity map again, progressing him along. It still becomes mainly, for the most part, zonally oriented in this region. With that cyclone right there, you can see that counterclockwise rotation around it, similar with this one in the Gulf.
That's clockwise around both.
Oh, yes, clockwise, sorry. Misspoke on that one.
And can you show me the surface map again, Derek?
Yes.
I see a vorticity strip in Colorado, Nebraska, Colorado and Kansas. I don't think that really has much to do with this weak disturbance in Tennessee. It's too far removed from it.
Okay.
It does have something to do perhaps with the precipitation that's to the northwest of the cyclone center, if you can even call it that. It's so weak.
Right.
That snow over Iowa, northern Illinois, and southern part of our own state by the time we get to next Friday. So
Right.
It's going to be interesting if this verifies. We see a little bit of snow
Right.
from a fairly weak upper vorticity feature, but it's not the one that has anything to do with this cyclone.
Right. And as this one keeps, he'll still progress to the east. We also want to keep our eye out on this one right here because the zonally flow is still hanging out in this region. Now we're having another system pull up on the Indo-Pacific on the west coast, and he has a small vorticity associated with him. Nothing major yet, but he'll bring conditions that influence this region, and also that will have further influence on us later into the week. What I really was interesting to do, I didn't notice this with you earlier, because like I said, I started focusing on this one, but as I was looking through the models again, as this cyclone starts moving along the east, he tails off and starts to fade out very easily. But as soon as he crosses over that into the Atlantic, where he hits that Gulf Stream, he explodes right back up.
Let's immediately, interesting point, let's immediately see if there's anything that changes at 500 millibars at this time.
So this was probably at midnight on the 10th, progressing through.
Yeah, look at that. You've got a really intense upper trough. That's part of it. It's really perfect coincidence of the arrival of some upper level support and the weakest stratification probably in the Western Hemisphere.
Right, and it really helps him out too, because when we were looking at him, he was still hanging out about 1,006, and as he progresses on, he drops all the way down to, I believe that's 992 and a 984 as he comes up. So he becomes a real developed storm as he progresses off over into
Yep.
the Atlantic. And as he progresses off too, we shift our focus to this region out over here, which is being on the 10th. That's where the vorticity maximum comes into of that associated system off the coast, and he'll bring precipitation to the Sierra Nevada range right up in here. So snow is associated with them, but as we can see, another one of these lee side features is appearing also right here, just due east of the Rockies again, and he's about to become intercepted with this vorticity maximum, and it's really going to help him develop into something special for us. So as he progresses along, I'm trying to show you the vorticity progression along with it. It follows that zonal flow over the U.S., which this ridge is still down here, having this clockwise flow, and this trough is coming down also. You get a nice vorticity maximum right here, and it has this area of low pressure sitting right here, right for the picking for it. So as it progresses along, which also you can kind of see that nice vorticity maximum come down from that deep trough that we were just looking at as he progresses off into the Atlantic also. Let's see, I'm going to focus on this one though, mainly because he has the highest impact on us currently in our forecast. So as that vorticity maximum passes through and reaches that region of the Rockies, this low takes off. So you see he develops rather rapidly along with it. So you see the temperature gradient coming in increasingly stronger right here. And as you progress along with it, another high starts making his way down too. And along with this, the vorticity maxima starts influencing him heavily along with it. You get a real deep upper level ridge.
Trough.
Or trough, yes, I'm sorry. I'm keeping tripping over my words today. Trough right up in here around southern Mexico, near El Paso. And as he progresses along, he develops a intense storm. That low pressure goes from about that 1,006, which we've seen similar characteristics earlier because other storms, drops down to 991. I believe it gets all the way down to 982 as he progresses along too. Yes, that's the lowest I've seen him get. And I'll try to show you the temperature advection too. I'm just not the advection, just the temperature on his own. We're at noon on the 13th. Noon on the 13th. You're starting to get this nice occluded structure with the cold air to the north following that warm structure coming up from under this southerly flow. And that's where the total snowfall and precipitation really impacts our forecast. This is getting in towards the end of the semester. So I got to fast forward a little bit because I zeroed all these in at the same time. Here's the precipitation following along with that cyclone. St. Louis, near that area, getting almost near, I believe that's 19 inches of snow associated is forecast right here. The max for us is about 9 inches from what I saw. Because as he tapers off and goes along, the 24-hour snowfall amounts for us starts to decrease. But he's going to become a nice, as if this becomes valid and the vorticity maximum falls along with them, it's going to pick up these low-hanging fruit that keep developing under that zonally flow from on the east side of the Rockies. And if one of them finally got some help from the Pacific system and developed into what could possibly be one of our first main snowstorms of the season. This is on the 13th, so still about 10 or 11 days out, so this might not become the full case of what actually happens, but at the moment this is what the models are pointing to. And that's snowfall for us.
Let's hope that it is.
If that were to verify, you're going to have cold advection from the south in like Indiana, Ohio, which is
That
kind of weird to think about.
is a characteristic of these well-wrapped-up storms, and it sometimes happens. It's kind of cool when it does.
Can we look at another model run valid at the same time? I'm just curious how consistent that is.
I'll do the North American. This is
Or even just a different time,
Yeah,
just change on the upper right.
Change the run time.
Okay.
It'll tell you the same verification time.
Let's see. I was looking at the 12Z1 this morning. A lot of it might not be.
Is that valid at the same time?
It's valid at the same time. There's absolutely
Yeah.
nothing there. After 6 hours of more data
I
ingestion.
wouldn't bet a whole lot of money on that.
Yeah.
It's a cool looking storm if it verifies.
Yeah, stay right there, Derek, and just keep doing that. So that's the most recent forecast run.
Right,
Let's go to
now
the
it's
one.
changed entirely.
Right, let's go to the one you were looking at,
This is the
060. That's the big storm. Let's see if that was there at the prior one, 0. No.
No.
So that's the unicorn.
Yeah.
That's the anomaly.
That's the unicorn that I
Some
got.
butterfly
So,
flapped his
no.
wings.
But it's
and-
nice that it's in there, but it's not likely to be the case if it doesn't keep on showing up.
Yeah.
Right.
It's pretty far out,
That was
yeah.
just the time I focused on this morning, not
Okay.
on, so investigations on.
It's a cool looking storm.
Yeah,
Which they say there's even high over there, not that intense.
yeah, everything's different.
Yeah, that's out in the hard to predict time.
Right. We really get past that week's threshold, it gets kind of cloudy. That is all I had to discuss also.
Okay, thanks very much.